our consumers out in the marketplace are requiring a much greater selection of products. It doesn't matter if they're selecting a bottle of wine and they want to make sure the flavor is just right for their palate, or if it's my wife looking for makeup and wants to make sure that the color is going to be just right for her complexion, or if it's a shirt or a sweater and I want to make sure the fabric feels nice, that it's the right size, and it's the right color. Everyone is requiring a greater choice in the products they buy. And this really started with the e-commerce taking place. Everyone wants to be unique, and everyone wants a product that's fit just right for them. Now, as a result of that, we're seeing the days of old when manufacturers would mass produce a single item and have it sit in inventory in hopes that that item would move is falling to the wayside. And it's really being replaced by unique, individual, single batch items, no longer mass quantity. And that's creating some challenges for the manufacturing space and how it can be agile enough to meet the demands of greater consumer choice. So as a result of that, manufacturers need to have much greater cost control. And there are a couple different things that impact cost. One, they need to make sure as they're increasing the amount of SKUs that they're manufacturing, that they don't have excessive inventory. So they want to order raw materials just in time and get those into production as quickly as possible in order to free up cash flow. And then on the other side of things, manufacturers have variable cost. The cost of materials are continuously increasing. Energy cost is always fluctuating, and the cost of labor is as well. And so they're really looking for alternative ways of offsetting that cost. And what they're starting to do is leverage advanced technology like robotics and manufacturing in shifts where energy costs are less expensive in order to get better control of their cost environment. Then we have our favorite topic, regulations and regulatory compliance. It's more important today than it ever has been that manufacturers are able to capture information about their manufacturing processes and the materials flowing through them in case they need to defend the product quality that's made it out to the consumer space. Now, the end user community is responding to these trends. What we're finding is they want to digitalize the entire manufacturing process. In order to do that, they're looking for machine builders to provide more advanced technology that can meet the trends that they're seeing in the marketplace. End users are starting to utilize analytics and artificial intelligence to better optimize their production environments. Now, artificial intelligence has been used for quite some time in our homes and in our automobiles. As a matter of fact, the cruise control in my car doesn't so much control the speed, but it controls the distance between my car and the car that's in front of me through a laser and a controller. So artificial intelligence is now commonplace, and as it makes its way down to the manufacturing environment, the same benefits can be realized to manufacturing. We spoke a little bit about regulations and regulatory compliance. End users are demanding that the equipment that they're installing is able to track the whereabouts of materials flowing through the production process. Now, this is done by serializing everything that's being manufactured and associating all the process variables of that thing being manufactured into a database environment and storing that out into the enterprise and having it archived in case they need to defend that that product was made to its design specification. Those that don't do this are really exposing themselves to lawsuits, and that can cost an organization millions of dollars. Now, there are several different factors as consumers are gaining greater choice in the amount of products they have available to them. We're seeing a lot of demand fluctuation in the manufacturing environment. And there are some really emerging trends that are driving some of that fluctuation. One that's been around a long time is seasonality. As we enter into the winter seasons, we're finding that sweatshirts, hats, and coats are in greater demand. But the whole advent of internet is really driving fluctuations in manufacturing. How many of you guys have done a product review for anything that you've purchased? Yeah, quite a few. I have as well. I bought a pair of shoes, delivery came on time, the product quality was very good, I gave it a positive review. When I buy anything, I'm always looking for the reviews that come back from other people that have purchased that product. Not only that, but social media is now affecting what's happening in the production environment. Smart manufacturers are looking at what people are liking and what people are sharing in order to forecast what product interest is going to be for a new product that's coming out. So as a result of having greater consumer choice and variability in the demand of production, we're finding that changeover time is increasing. And with the sort of advanced technology that we have in automation controls today, this is pretty unacceptable. So we really need the machine builder community to build more flexible and agile equipment to reduce the changeover time to maximize production throughput. So in order to address these trends and end user responses and the impacts on manufacturing, we see the machine builder community more heavily adopting industrial automation technology than they ever have in the past. And this is a great thing, except for a lot of the controls that are going in the environment aren't developed to communicate outside of that machine. And so that's a change we need to see in the OEM environment, is to look past their machine and understand how that machine is being used in the end user community and sharing information throughout the enterprise. Now, an OEM does a really good job during the sales and promotion process in defining what the speed and throughput is of their machinery. And now the end users are using key performance indicators to really measure the designed throughput and speed and output of that machine against what it's currently yielding. And those KPIs are being shared with the machine builders so they can provide more intelligent services to be more accountable for their stated performance when the end user bought that machine. So transparency and information and an increase in information accessibility back to the machine builder is something that the OEMs are looking to do with their end user community. Another phenomenal thing that's happening, which is really helping small to medium-sized companies, is this thing called machine as a service. Machine builders are now starting to look at producing equipment and providing it to an end user on a lease while they make performance guarantees. So they will guarantee a certain output of that machine over a certain period of time. And it's really a win-win for both the end user and for the machine builder. The end user doesn't have the upfront CapEx expense, and over the life cycle of that machine, the OEM is actually making more revenue than they did if they sold the machine outright. So machines as a service is an emerging opportunity for machine builders, and as we see manufacturers decreasing their investment in capital expenditures, machines as a service is an excellent offering to differentiate themselves. We're also seeing machine builders adopting sensor technology at a much greater pace than they ever have before. Sensors are abundantly available, and they're providing critical information about the manufacturing process and the materials flowing through those. And so if we're going to aggregate information and make it available for track and trace, we need greater adoption of sensor technology to make sure that it gets centralized in the controller and shared with the quality control system and the rest of the enterprise environment so that we can do better compliance to regulatory issues. Now, I've been in the manufacturing space for longer than I'd like to admit. And when I started in the manufacturing space, we used a reactive maintenance model. And at that time, what it really meant was, we're going to run the machine until it dies on its knees. And what we really learned throughout that process was that lack of production output overweighed the cost we should have invested in maintenance services. So we moved to something called a periodic maintenance model. And in a periodic maintenance model, we would take a machine out of service and we replace parts based on a theoretical time frame that we felt the most common failure point would be failing. And that didn't work well either, because what it really did was it increased the amount of spare parts inventory we needed, which just drove up cost. So we moved to a proactive maintenance model. In a proactive maintenance model, you look at the life cycle expectancy of components on a machine, and as a component nears its end of life, you take that machine out of commission and you replace it. But those three previously mentioned maintenance models did two things. One, it unnecessarily took a machine out of production, and two, it had me replace a part that didn't really need to be replaced. And so what we're really seeing is the need for greater adoption of predictive maintenance. Today's industrial automation technology is processing at the edge not only the health and wellness of the automation controls, but the health and wellness of the machine that those controls are controlling. So we are now able to predict the maintenance needs while making automatic adjustments to increase the production throughput while notifying those that are going to service the machine. We also have artificial intelligence and cloud technology. Inside of servo products today, through artificial intelligence, we're able to measure vibration and resonant frequencies that's taking place in the machine. And as equipment is used over a long period of time, it begins to become fatigued. And that machine needs to continuously be tuned. The days when a machine would only be tuned at the production side of the machine builder are really gone now, because technology has become so much more advanced that machinery can be continuously tuned as it starts to understand the maintenance needs. And as it's making those automated changes, it's notifying key personnel that those changes were taking place so they can schedule downtime without affecting the production schedule. Now, for the most part, the mechanical systems of this machinery hasn't been touched in the last 20 years. And I think there's a great opportunity that's been missed. With robotic technology, manufacturing equipment becomes much more agile and much more flexible. And a robot can be taught to handle products of various sizes, weights, and shapes much easier than a standard mechanical system. So we really need the OEM community, as they're in the mechanical design cycle, to consider what opportunities they would be afforded, how their organizations and equipment could be better differentiated if they incorporated robot technology in their design cycles. Now, machine learning is also a very important enabler. When you have edge computing now embedded in the industrial automation controls, there are programs running in there that understand the current state of the manufacturing equipment and is comparing that to the theoretical ideal performance of that machine. And when it's not running at its ideal performance level, then it's important that we get not only the maintenance staff and the engineering staff of the manufacturer informed that there's an impending issue happening, we communicate that over the cloud to the machine builder so they can provide more intelligent services. Not only that, but they're using that machine learning technology to develop better products. They understand where the failure points are in their machinery today, and they're incorporating that into the design cycle of the next generation machinery. Now, we've talked about a lot of different things today, and so the question I often get asked as we're consulting with customers is, how do we get started? The fundamental thing we need to do in order to create machinery that is smart is to connect it. If our machinery isn't connected with one another, then there's no way we can create a smart manufacturing environment. Now, it's critically important as we're networking these components together that we're doing it over a standard Ethernet protocol. And not just any Ethernet flavor. We need to make sure that the Ethernet protocol being used is separating communication, that control communication remains completely deterministic while affording enough bandwidth to aggregate all that sensory information and share it throughout the enterprise environment. So connecting the systems is paramount in order to have smart manufacturing environments. The second thing, as I mentioned, is integrating robotics. As many of you know, we have two serious issues that are affecting the manufacturing space. One is the retiring workforce. And the second is those retiring workforce people aren't being replenished with new labor. So there's a real shortage in people coming into the manufacturing space. In order to overcome that challenge, we really need to look at greater adoption of robot technology in the manufacturing environment. Particularly in packaging, robots are not only used for picking and placing, assembling, case packing, and palletizing, but where we're finding opportunities to leverage robotics is in work cell concentration. Look at how much space on a manufacturing floor is consumed by having individual work cells for every one of those functions. Robots can multitask, and you can have multiple robots working in a coordinated fashion with one another. We're now really talking about consolidation of work cells and doing the same amount of work in a smaller footprint. So it's a huge cost savings for manufacturers. Now, Mitsubishi Electric has been deploying cloud and edge computing solutions for quite some time now. Now, historically, cloud was thought of as being something that's vulnerable. But if we really think about it, cloud platforms that are offered in the larger data centers are much better protected and staffed than anything we can offer on-premise. So the notion that a cloud platform is insecure or vulnerable to cyber threats is just not a case anymore. What we really need to be protecting is our on-premise solutions, which don't have the same investment as those that are out in the data center. Now, when you couple cloud computing with the embedded edge computing that's offered in today's industrial automation solutions, we're really offering machine builders a much easier opportunity to create smart machinery for the packaging space. Now, I want to talk a little bit about artificial intelligence. Mitsubishi Electric is a huge conglomerate. We do many things. Many of you may not know, we own Kirin Beer, so we make beer. We own Nikon Camera, so we're in the electronics manufacturing space. We build solar panels, elevators, escalators, HVAC systems, automobiles, and I'm here talking with you today about industrial automation and factory automation. So we've been using artificial intelligence in automobiles and security systems, in satellite systems for over a decade. And there's a huge opportunity now that artificial intelligence is being embedded inside of the industrial automation controls, that we can benefit in the same way that those other industries have. We talked about a lot of things today. We talked about emerging trends in the packaging space. We talked about how the end user community is addressing those. We talked about how manufacturing is being impacted. And we talked about how OEMs are responding. But in a 20-minute presentation, it's not nearly enough time for you to absorb everything that you may need to know. And so really what Mitsubishi Electric is offering is a partnership. We want to consult with you. We want to learn about your business. We want to make recommendations that enable you to build smarter machinery with the goal of creating a smarter manufacturing environment.